Good morning. Welcome to ArcGIS Runtime, working with your maps online and offline. My name is Luke Smallwood and I'm joined today by Nick Furness. This session is the first of 3 sessions that we're running in the offline workflow area. The second session is entitled Editing Your Data Online and Offline. The last session is about optimizing your data for working offline. And you want to hear about some best practice or some tips and tricks. The agenda for today really begins by asking a high-level question. What's the connectivity strategy for your application? That's something that we think is really key for offline workflows when working with runtime. You have to design for connectivity right from the outset. That's because there's a number of different workflows that you can adopt that work well in different scenarios. So for example, is your app always connected? Does that mean that you have access to good network, which means you can always access backing services for your data? Or on the other hand, is your app always disconnected? Maybe you're in an environment where there's simply no network at all. And in that case, you need to make sure that your device has all of the data necessary to give your user a good experience without relying on any connection at all. And there's a kind of middle ground where your app is occasionally connected. Maybe you start out in the office at the beginning of the day and you have access to network there. But then you need to expect that there could be interruptions due to connection problems. Or maybe your users are deliberately remote working out in the field where they're not going to have access to the network. And the key point here is that if you fall into this kind of workflow, you need to plan to work as if you were always in a disconnected environment. That means that your users will be able to have a good experience when they start in the office, but also when they go out into the field. And we see this as one of the most common workflows with runtime applications. You can further refine that workflow by keeping your offline critical business data offline and making sure that's on the device. But you can supplement it with auxiliary online data when you have a network connection available. And as well as considering how you're going to have information on your device or whether you're going to access it from a service, you also need to think about your update strategies. So how are you going to either push updates that you make on the device or receive updates from other users in your organization? All of these things will feed into what kind of connectivity strategy your application uses. And the good news is that Runtime has APIs that target each of these workflows. And we're going to have a look at those today. The title of this session was Working with Maps, Online and Offline. So what do we mean by the word map? Well, it's really one of the most central concepts in ArcGIS. And that's because it's the same term that we use right across the ArcGIS system. You can author a map using ArcGIS Pro, maybe a desktop user, a cartography expert, or you could create one from an API like Runtime or JavaScript, or you could create them from an online client with ArcGIS Online. And the key thing is that we can use any of these different applications, any of these different clients to consume the same map document. And that's really powerful because it means right across your organization, users can be making use of the same information that describes the map. It also means that we can share updates to that map. So if we need to add new information or change the way that things are displayed. The map itself is made up of a number of components. We have operational layers that describe the features and data. We also have symbology that describes how the features and the rest of the map should be displayed. You can configure pop-ups that describe how information should be displayed to the information if they identify or select a feature, for instance. We also have base map layers that provide that critical contextual information about where the map is. And lastly, there's metadata in the map that allows you to record information such as who authored the map, any access and use constraints, and other information like thumbnails. We're going to begin by looking in more detail at the first scenario that we discussed, where you're always connected. You've always got access to that backing service. So here we're going to look at online web maps. As we said, we're always connected here. And that means that the data that we use is located in services. This is a service pattern. And it's exactly the same approach as you would use with JavaScript API. For example, you'd be using the same service data. Depending on the configuration of the backing service, if the service is set up to use it, this can be an editable workflow. So you can edit data directly on those services. The web map itself can be authored, like we said, with ArcGIS Pro, with Online, with Runtime, and other clients across Esri. I'm going to take a quick look at the structure of the web map. We begin with a portal item of type web map. And this is a light portal item that provides some metadata that describes the map itself. And it points in to the JSON document that describes the map. This is a document that contains lots of information, all that data that we saw about what layers are involved, how they should be symbolized, metadata about the map itself, scale, and so on. And the map itself then points to a number of layers that go together to make up the map. For example, we might have a tile layer. Typically these are base map layers that you use to provide context to your map. And you'll see here that this layer within the map addresses a tile service. So it addresses this online service that provides the tiles. We could have operational data, we could have feature layers in the web map. And just like the tile service, these are addressing a feature service, which serves up that feature information. And you'll note that we could have many feature layers pointing to information in the same feature service. So we can actually use that same information time and time and again for different use cases. And we can go further. We can customize the underlying feature service to override it in different ways. So in this example, we have a number of feature layers that are pointing not at the backing feature service, but at a portal item of type feature layer instead. This feature layer lets us describe new symbology or new capabilities for the underlying feature service. So, for example, we could change the way features should appear, or we could reduce the capabilities of the feature layer to make it read-only, for instance. We might also see vector tile layers in the web map. Vector tile layers are an extremely popular form of base map, again to provide that contextual information for the map. And here they point to a vector tile service. But just like with a feature layer, you can actually override the underlying vector tile service by customizing how the vector tiles are displayed to the user. And this is exactly what we do when you see a custom styled vector tile layer. You'll see that as well as referencing the underlying vector tile service, it also points to a set of custom resources that let us control how the vector tile will be displayed. So in terms of using a web map in runtime, I've got some simple pseudocode here that shows the workflow. We begin with a portal. The web map is contained on a portal, so we construct a portal with the URL, an example being arcgis.com. At that point, we need to handle authentication if any is required. And then we're ready to construct a portal item using that portal instance and the item ID of the web map itself. So every web map has a unique portal item ID. We would take that portal item and pass it to the constructor of a map. And then all we have to do is bind the map onto our map view. And the map view from that point will take care of everything else. It will load the map and request any of the data that we need to display and render the map. And it's as simple as that. If we move on now to the second scenario, where unlike we're using an online web map, here we're always disconnected and we're using an offline map. In this case, we're going to look at the workflow where it's been authored in ArcGIS Pro. In the always disconnected scenario, we are producing mobile map or mobile scene packages which are authored with ArcGIS Pro. And it's important to point out that these are read-only workflows, so it's not possible to edit feature data in a mobile map or scene package and then push it back to ArcGIS Pro. But what you do have is all of the information you need for your offline map bundled together in one of these packages so that everything is easily shared and put on the device so that you can work in an always disconnected fashion. Typically the package is side-loaded to the client device, and that can be done in different ways depending on the operating system of the device. Whether it's Windows UWP, iOS or Android, they all have their own way of sharing files onto the device. Another option is to take your mobile map or scene package and put it online in a portal, for instance, and then allow client devices to download them when they need. Once the package is on the device, they never need to go online again. They can simply open up the mobile map package and work offline. Mobile scene packages created from ArcGIS Pro are the only option for offline 3D workflows with runtime at this point. So there's no way to take an online scene layer, for instance, and use that to create an offline package. You'd have to do that using ArcGIS Pro. This workflow also allows you to make use of the publisher extension within ArcGIS Pro, and it lets you set things like the expiration date and time for a mobile map package. That's really useful if you have data that isn't going to be relevant or accurate beyond a certain date. You can publish it with expiration, and then runtime users will be able to know that their map package is no longer correct or shouldn't be used beyond this date. You can also publish a mobile map package including transportation networks and locators. Again, all this data is contained within the package. It allows you to do offline routing and network analysis. So you could do turn-by-turn location routing. With a locator, you can do geocoding and reverse geocoding. So some really powerful workflows are possible when you include this kind of information in a mobile map package. And a newer workflow that we've introduced in the last few releases is the option to include online layers for supporting information like weather or traffic. So that means it's possible to take your critical business data and put it in the mobile map package. Now that's always offline, that will always work. But if you have access to an online network at any point, you can bring in that additional information like weather or traffic. We couldn't take this offline because it's changing all the time. But when we have access to the network, it can provide good additional information about site conditions. So taking all that information together, you're able to create a map in ArcGIS Pro that contains the information you want. And it's very easy using the tools within Pro to just publish a mobile map package. And then you take that offline map and away you go. We'll look very quickly at the structure of an offline mobile map package. And you'll see that it's very similar to the structure for the web map that we saw earlier. So again, we have a JSON document that describes the map in terms of symbology, metadata, and so on. And again, the map document describes a number of layers. This time the layers don't reference services, they reference files within the package. So here a tile layer, exactly the same information that we saw with the web map, but rather than referencing a tile service, it will point to a TPK or the newer format of TPKX, which is a tile package contained within the mobile map package. You could also have feature layers that point to a mobile geodatabase. As we said, these cannot be edited, but they contain all the information you need to symbolize, identify, select features within that geodatabase. And again, we could override the basic settings for symbology and so on that are included within the geodatabase and override those feature layers to have a different experience for the user. We can also have vector tile layers. Again, really useful for base map information. But rather than pointing at a vector tile service, these come from a VTPK or a vector tile cache. Again, if we want to customize that vector tile layer so that it has a custom style, we can do that using a VTPK for the underlying vector tiles, and then some custom style resources that control how the tiles will be displayed.
And now I'd like to hand you over to Nick, who's going to give us a demonstration of displaying maps from a mobile map package.
So I want to take a quick look at generating mobile map packages. You can do that in Pro. You generate an MMPK file that you then have to sideload onto your device. Here I've got a Pro project that has a couple of maps in it. So looking at the same data, just different views in the same project. And if I just want to export the current map as an MMPK, I can pick the map, I'll go share and use the mobile map package tool. This is now going to create, you see it says share the stormwater map, that's this map here, as a mobile map package. It's going to create an MMPK of just this map. I'll give it a location, specify a little bit of stuff about what I want included in here, how I want to clip the data. Maybe I've got a polygon layer that will define an area of interest for me, and I can package that up. Clicking package will generate an MMPK. But MMPKs are mobile map packages, so they can include more than one map. And let's say I wanted to create one that had both the overview and the stormwater map in it. Well, in that case, I go to the GP tool, and I look for the Create Mobile Map Package tool. You can search for it. It just happens to be in my history here. So I'm going to fire this up. And when it shows up, we'll have a few options. This is very similar to the other tool, only now we get the opportunity to select from a number of different map definitions that we have defined in our project. Still specify the MMPK location, and there's a little more information here. Since we've now got multiple maps in there, we can say I want to export the data covered by the union of those map areas. And then I'll just go ahead and run that. That generates one MMPK with multiple maps with just one set of data that all those maps make use of. So let's take a single map MMPK and look at what that looks like on an iPad. So here I've got Dropbox with an MMPK, and I've written a runtime application that knows how to open MMPKs. I'm going to tell Dropbox to just open it in that application. And that MMPK is now opened up by runtime. I can zoom in. We see all the feature details. We got the base maps. We can navigate around. It's all drawn directly on the device. So let's take a look at the code required to open that. It's really very simple. When iOS called in from Dropbox to say I've got this URL, this file at this URL, Here's that URL. I go ahead, I create a mobile map package from that URL. I load that mobile map package to understand what's contained within it in terms of the maps. And I get the first map out of it, and I just apply it to the app's map view. That's all it takes to display that map from the mobile map package in the map view on the iPad and make it fully interactive.
Thanks, Nick. A great demo. Hope you can see how easy it can be to create mobile map packages in Pro, publish them, and then consume them in runtime. So have another quick look at the code used in that workflow. It's the same really for a mobile map package or for a mobile scene package. We need the path to the package file, either .mmppk or mspk. We pass that path to the constructor of the mobile map package class to instantiate it. And at that point we have to call load, and we wait because loading is an asynchronous task. And when loading is complete, we'll have a mobile map package which has an array of maps. And any of those maps can be passed to the map property of a map view, just like we did with a web map. And that will take care of loading the layers, rendering and displaying them on the map view. And as I said, it's exactly the same with a scene. We would construct a mobile scene package with the path to the file. We call load and we wait. And then we could take one of those scenes and bind it to the scene property on our scene view. Okay, moving on to the second connectivity scenario that we're talking about today. We want to look at the case where we're occasionally connected. That's the very likely use case for a lot of runtime workflows. As we mentioned, you might begin in the office with a good connection, but then you go out into the field, and we need to make sure that our apps are resilient to that loss of connectivity. And here what we do is we actually take a web map offline. So we begin with an online web map, and we're able to take it offline so that we can use it in the field. And again, that web map could be authored in ArcGIS Online or ArcGIS Enterprise, and it's entirely an online service-based web map at this point. Critically, there's some settings you need to do to enable the offline mode on the web map. That includes setting some capabilities to allow you to edit and sync features in the map. And at a high level, what we're going to do is we're going to download the map definition and all of the package files that back the services in the web map to a mobile map package directory, just the same as we did when we published from Pro. And then we'll have an offline map or mobile map package that we can use on our device just in the same way, same pattern we saw a moment ago. But how do we actually take the web map offline? We've got two workflows to explore today. The first is a pre-planned option. And here it's the web map author or the administrator of the service who would define what the web map uses to be taken offline. So they can actually specify the area of the map, the area of interest that they want to have taken offline. And that is then generated ahead of time so that end users can simply download that pre-planned offline map. The second approach is an on-demand option. And here, rather than the web map author defining upfront what's going to be taken offline, it's up to the end user to specify their own area of interest and any other settings they want before they take that map offline. So two workflows that both essentially take a web map offline, but have quite a different set of inputs. They have different implications for the workflow. The pre-planned workflow is less flexible because the author has to define the map up front, but it's extremely scalable because it means that many users can all download those same maps very quickly. They don't have to wait for any services to be generated, and they can just simply download the map and take them into the field. The on-demand workflow, the user has a lot of control over what they want to take offline, but things can take a bit longer to generate because you're creating a new offline map every time. When we talk about offline maps, they're made up of a number of offline data types. And we mentioned some of these in our diagram of a web map and a mobile map earlier on. So we talked about vector tiles, raster tiles, features, tables, and feature collections. And all these types can be taken offline in runtime and backed by appropriate data. We'll cover some of these settings in later sessions to do with the offline workflows. As I mentioned, there's a number of settings that you'll need to do to ensure your map can be taken offline. So you can see that I've enabled a web map for offline use here. And particularly for feature services, you'll need to make sure that your map is enabled for editing and enabled for sync. And that would give you the capabilities of taking an online feature service and generating a mobile geodatabase for it, which is how we take that data offline. Going to look in a little bit more detail on the pre-planned workflow, which I mentioned earlier on. In this example, we've got our web map made up of a number of layers, and we've defined an area, area 1. So as I said, it's the web map author who actually defines this area ahead of time. He's got one area defined here, but there could be many. And area 1 itself is then created as a portal item of type map area. And that portal item points to a number of other portal items that correspond to the layers that we're taking offline. So again, for tiled layers, we'd create and store a TPK. For vector tiled layers, we'd create and store a VTPK. And for feature data, we'd create and store geodatabases. And those are all staged in the portal, awaiting download by anyone who wants to use that area. And again, we could define more and more of these areas, and they'd be stored in exactly the same way as portal items. And the important thing is that the generation could be done at any time, perhaps at a very quiet time for the servers, maybe Sunday night before workers come into the office on Monday morning. And then when anyone's ready to take that area offline, they're simply downloading. There's no work being done on the back end. The author creates the map and defines any map areas. And then we kick off a back-end task on the portal to generate all those packages that make up the mobile map package. And that can be configured to run again on a schedule maybe every week, so that your packages will be the most up-to-date available. The Runtime app is able to inspect the list of areas that the map author has created, choose the one that they want to download, and simply download those packages. And they'll get the most up-to-date set of the packages based on the latest run of that refresh schedule. And the key thing here is you can see that many users can all download the same map area without putting any more load onto the backend. And that's one of the things that makes this workflow so scalable. Okay, I'm going to hand you over to Nick again, who's going to give us another quick demonstration of authoring and using pre-planned map areas.
So I want to take a quick look at a couple of aspects of working with the pre-planned workflow. Here we are looking at the familiar web map again. And I'm going to jump into its description page. So we can go into the settings here and take a look at offline. And you can see, okay, we've got offline mode enabled again as before. We can see there are 5 map areas defined. So let's take a look at what that means. We'll click this button, up pops the Map Manage Areas interface. I'm just going to zoom in a little bit here so you can see, okay, we've got that same context. Here's the same data. We just happen to be out of scale range at that point. But we've got these 5 areas we've already defined. We can hover over them. We can take a look at one of them. Let's take a look at this Columbia Estates area. See there's some little hints and tips here which we can dismiss. We've got some information about this area. How often does it update and when? When's the next update scheduled? So as data is changed in the map area, ArcGIS Online or Enterprise will go ahead and repackage that on this interval. We could edit this, delete it. Let's go ahead and create a new area. We'll do that and draw an area right up here. Let's call this Windscape Villages. We say how much detail we want on the maps. Now we've got a vector tile-based map here, so we can zoom all the way in without worrying about generating too many tiles necessarily. Every week? Sure, every week. Well, let's do every day again at 5 a.m. And we'll save this. So now it's created that additional area for us. It's busy packaging it up initially. It'll do that the first time you create it. It's going to create that initial package, and then it'll revert back to the schedule. So let's look at that running on an iPad. Here I've got pre-planned application. It's pointing at that web map. You can see it's already picked up that Windscape Villages option. Now I'm not going to load that because it's still packaging right now. We can go ahead and use one of the other ones, like Columbia Estates. We'll tap on that, download it. It comes down over the wire really quickly, and we end up with this map, this fully interactive map with those vector tile-based maps sitting behind our operational data. And as we've talked about, we can edit this, we can synchronize this back. But let's take a look at what code was involved there. Now, the important thing here is to connect to the online map. So like we did with the on-demand workflows, we create a map. We have here our portal and our portal item, and we just create a map from it. But this time, rather than showing it in a map view, we're simply going to create an offline map task from it. Now, we're going to use this offline map task to display that list of areas in the app's user interface. So here we're calling this method here, passing in the offline map task, and all we do is we take the offline map task and ask it for the list of available pre-planned areas. That goes off and interrogates the web map for that list of available areas that we can set on ourselves, and this triggers the user interface to update itself. We're not going to look at the code behind that, but the user interface will now interrogate these areas, pop up the images for them and descriptions, and present them as a list. Once the user picks one from the list, then we jump down into this download area function. And here we're past one of these pre-planned map areas, the one that the user picked. We'll take the offline task and we have a download location. So this is where the offline map will be downloaded to on the device. Using the offline task, we get a set of default parameters to download that area. That's to say, given that area, we ask the offline task, what's a sensible set of parameters that we can use just to download that area? Usually you won't need to mess with this, but this is an opportunity once you've got these parameters to update specifics. Given those parameters, we then just create a job. We do this using the offline task again, and we get a download pre-planned offline map job using these parameters and downloading to the location that we decided we're going to download the map to. We hook up this observer to track progress, and this ties into the user interface that we saw. And then simply we kick off the job. We call job.start. And there are two handlers on here. There's a status handler that gets updated whenever there's a new message to display. It's optional to keep track of that. And then we have the completion handler that's called once at the end when the entire map has been downloaded and is available to use on the device. So here we get a result in, and we'll store this result away and just tidy up the user interface. This is where we hide that panel that showed all the various pre-planned map views to display. And once the user interface has tidied itself up and dismissed itself, and we're looking at the map view again, the application calls into this, passing in this pre-planned offline map result, which is the result we stashed away up here, and it has an offline map property on it. It's as simple as just getting hold of the map view and setting its map to the results offline map property, and the runtime will display it. So that's all it took to list the areas, download one, and display it in a map view in the runtime.
Thanks, Nick. So another good presentation showing just how easy it is to choose a pre-planned map area in runtime, download it, and start using. So just taking another quick look at the code used in the pre-planned workflow. We begin with a web map, and the key player in the API here is the offline map task. We construct the offline map task with that web map, and again we load it because it's asynchronous. We wait. That gets the offline map task ready with all the layers and the definitions that are contained within the web map. We can then fetch the set of pre-planned map areas that belong to that web map. Again, it's an asynchronous operation. When that completes, we'll be able to inspect that list of map areas, maybe show them to the user in some UI and let them select the area that they want to take offline. We use that area to construct a map area object, and we use that when we create default parameters for downloading an offline map on the offline map task. So that will set up our parameters ready to take the specific map area offline, and it'll give us an opportunity to adjust any of the parameters that we need to suit our particular workflow. When we're ready, we just pass those parameters to the task along with the path that we would like to download our offline map to. That job will then start running. We can get progress updates on the download. We get a series of messages and status reports. And once it's complete, we simply take the offline map result and bind that as an offline map to our map view. So this really follows the task pattern that we'll see elsewhere in runtime. So this slide is looking at a kind of generic high-level view of the task pattern, which is what we're using the offline map task here. We create our task object, and we have a create default parameters workflow. So from the task, in this case constructed with a web map, we're going to create a set of parameters. These will be filled in with sensible default options, either based on the typical workflow or based on the data that we're interacting with here with the web map. But we can always adjust those particular parameters to suit our workflow. Those parameters then get fed back into the task to create a job. So usually the job is created using these parameters, and the job is an asynchronous job, often hitting services that we can start, we can listen for updates, and when it's finished, we'll have a result, which is what we're aiming for here to take a map offline. So the result will be the offline map. And we have a similar task-based pattern for offline map task, for offline map sync task, where you're pushing changes back up, but also for exporting underlying services like the export tiles task, the export vector tiles task, geodatabase sync task, and some of the routing tasks as well. They all follow a quite similar pattern of using a task with parameters to create a job and then obtaining a result. So we looked at the pre-planned workflow. Let's take a quick look at the on-demand workflow. Again, we have a web map author and we have a runtime app that wants to use that map offline to collect, synchronize, and so on. So the web map author creates the map, and that's all they have to do, because all of the work to take the map offline is done or kicked off by the runtime app. So the user of the runtime app is going to specify the area they want to take offline. So that includes the extent that's going to be taken offline, also any levels of detail to describe how much data is going to be taken offline, and a set of other parameters to do with base map settings and how features should be taken offline, whether they should include attachments and so on, or whether we just want an empty schema for collecting data. So a whole set of parameters that you can adjust. And then once you've specified that, you begin the operation of downloading the offline map, which will create all those packages just for this one map. So the on-demand workflow looks a bit like this. We load the online web map. You would choose your area and the scale range, and then you would create the parameters. You could use default parameters, which can be based on the recommended settings that the web map author has set up. That can include things like downloading a schema-only version of the data. That reduces the amount of data that you're downloading. You won't be able to see anybody else's features, but if you're just out collecting data at the start of a project, that's a good option. You can also choose specific settings for whether you want to download attachments for existing features. Again, if you're just collecting data, maybe you don't need to see attachments from previous surveys. Do you need to download a base map? Base maps can involve relatively large file sizes to download and also take time to generate. If instead you could use a local base map that's already on your device, that can be a big saving in terms of download time and disk space. And we'll have a look at some of these options in more detail in the optimizing your data for offline workflow session later on. And then you would take those parameters to generate your offline map. So we're going to have another demonstration from Nick that's going to look at how we take a map offline using the on-demand workflow.
So let's take a look at the on-demand workflow. The on-demand workflow and the pre-planned workflow, for that matter, both begin with a web map. Whether you author that web map in ArcGIS Online or Enterprise, or in Pro and publish it up, the web map is central. So here we have a web map with a few layers in it. We jump over to the settings and take a look at the offline settings and see that there's this Enable Offline Mode checkbox. If that's on, you can take your web map offline as a whole. You may need to make sure that individual layers are also enabled for offline mode, but by and large, you should be good to go. So let's take a look at what taking this web map offline looks like from an iPad. Here we've got that same web map, and I'm going to navigate around. We're currently looking at the online version of it. I'm just going to take a portion of it offline. Now, Runtime is talking to the server at this point, to ArcGIS Online or ArcGIS Enterprise, and kicking off a number of jobs on the server side to generate the components that Runtime needs to be able to use this map offline. Here we're pulling together some base maps and some feature services in the form of offline geodatabases. And we'll pull those down to the device and use them to display the data. Now, in addition, ArcGIS Online and Enterprise will pull together metadata about the map, information about layer visibility scales, pop-up overrides, bookmarks, and so on. And that gets pulled down as well, and all hydrated and used together by the runtime to create a full offline map experience. So it looks like right here, we've got the geodatabase down already. We're just waiting for these vector tiles to finish generating and download. Once that's happened, You see the download happens really quickly, and we have a fully interactive offline map. Now what you'll notice here is that some of the features extend beyond the extent of the base map that we were interested in. That's because by default, the map will get complete features down. We don't clip anything. That's important if you're doing editing. So the offline map task allows us to override settings for specific layers if we need to. So what we could also do is we could get rid of this, and we can pull this down with a larger base map area. So again, this is kicking off a similar kind of process as before. In fact, it's exactly the same process, but the parameters for the base map only have been overridden to get a much larger area. We'll look at that code in a bit and compare the code with the overrides and the code without the overrides. So we can see we've got the geodatabase already. We're just, again, waiting for those vector tiles to be generated. Okay, so now you can see that's the extent of the features that we were interested in. You can see some of them extend way beyond that. Only this time we've managed to get a base map that's larger and can cover the area. So what's happening in code here when we do this? So we begin by opening a web map in the application. We do that a lot like we did for working with an online map. Give it a portal ID, portal, and we create a map from it. Again, we're opening that in the map view, but we're also in this case creating an offline map task based off that online map. Then when we click the download button, we generate an area of interest that we want to get. That was on the iPad, that was shown as the red outline. We take the offline task and we generate a set of default parameters considering that area of interest. Once we get that back, we can just say download the on-demand area using the offline task with those parameters. We can specify a location on the local device where we want to keep that offline map. That kicks off this download on-demand area function here. We're just going to set up some UI for the progress bars. We're going to create a job. Here we take the offline task again. We say generate an offline map job using those parameters to download to that download location. We're going to hook up some progress bar observation stuff to keep the progress bar up to date. And then we just start the job. Now there's a status handler, and here's where we add all those little messages to show what's happening on the server side. But the key bit here is this completion handler. When that comes back, we get an offline result, and we're just going to close that download panel. What we do with the offline result is it ends up in here. We just take that map view that we had, and we take the offline map out of that result. So the result being passed in here is this bit here. We just take the offline map out of there and show it in the map view. That was the first demo where we got the base maps clipped to the area of interest. But if we wanted to override the area of interest a little bit, we just add a little bit of code here. So in this case, we're going to call an override to this function with a buffer amount, and that's described here. So all we do that's different is we generate offline map parameter overrides given the parameters. So we begin, as before, by generating parameters considering the area of interest using the offline task. And then we say, okay, now we've got those parameters, I'd like to override some of them. So please give me a set of overrides that I can modify. And what that comes back with is a really fine-grained set of parameters that will be used to take that whole map offline. Base map layers, operational layers, and so on. And we can go in and we can tweak any one of those settings that we need to. In this case, we want to tweak the setting for the base map layer. So we look at the online map and we just get the first base map layer in it. And we also calculate a buffered area of interest. So we had that initial area of interest that defines how the features are being clipped. We actually want to buffer by a bit more. So we get an override key by providing the base map. And we say for that override key, we want to update the area of interest to this modified, buffered, larger area of interest. So this bit of code here is just saying for the base map layer, get a larger area. And then we just jump back into the code that we had before. And the only difference is that when we create the job, we use a different generate offline map job call that also accepts these overrides. So we have the default parameters that we had before. We also have the per layer overrides that we've tweaked, and it comes down to the same download location, and everything else is exactly the same. We get the same kind of job back, we hook it up to the UI the same way, we execute it the same way, and when we get the result back, we drop that into the map view exactly the same way. So that was getting a web map offline using its default settings for a given area of interest, and then taking a look at how you override individual settings for the contents of that web map if you need to tweak or change anything.
Thanks, Nick. So that was a look at taking a map offline with the on-demand workflow. Again, taking a look at the pseudocode here, we can see that just like with the pre-planned workflow, we make use of the OfflineMap task, which again we've constructed from a web map, and we've loaded and waited for the load completion. Again, we're able to create default parameters for taking that map offline, but this time we supply some more information. We're supplying the area of interest, the geographic extent that we want to take offline, and also the scale range, so that describes whether we want very high detailed base maps or whether we're happy with a simpler, less highly detailed base map. Once we have these parameters, we can adjust them to suit our workflow. And then when we're happy with the parameters, we simply make a call to generate an offline map, passing those parameters along with the download path where we want to create our offline map. And again, we start the job and wait. Once the job completes successfully, we can take the offline map from the result and bind that to the map view. So we've looked at a few different scenarios about working with maps when we're connected or when we're not connected, or when we have that occasionally connected scenario. The last section of this presentation is considering how we can update those offline maps. When something's changed on the server, what can we do to get our map back up to date? And really it all depends on what connectivity strategy you're following with your app. So again, if we think back, if we're using an always connected scenario, well, that means that we're making use of an online web map. And in that case, we're always up to date. The features in our map are being directly read from the backing feature service. And that means that if anybody edits that feature service, we have access to those updates straight away. And it would go the same for any other layers that are in the web map. On the other hand, if we're using ArcGIS Pro and we have an always disconnected model, then remember it's a read-only scenario. We've got no way of generating updates or bringing in changes from that mobile map package. So the workflow here would be to recreate the mobile map package when it's expired and redeploy it to the device. So that would be updating from ArcGIS Pro. In the third scenario, where we're occasionally connected, we have some API to help support synchronizing your offline map with changes to the online services. And there's an OfflineMapSync task that will help centralize this API. You still have some questions to answer. How and when do you update? Is it something that you need to do every day? Maybe it's once a week. Maybe it's something that you do on an ad hoc basis when you are able to find a connection, whenever you can get a connection. It's also important to think about whether you are needing to download changes from other users so that your map is up to date. Or maybe you have local changes on your device that you need to upload to the service. Now, in this session that we're looking at just now, we're not really considering editing workflows. That will be covered in the second session that I mentioned. So we can really just concern ourselves with downloading changes from the services. So as an example here, we've got on our device here, we have an offline map, or rather we have a web map that we're using with a connection to the portal. And we can use the pre-planned or the on-demand workflow to take that map offline. And that's fine, we're now able to go offline, we lose our connection, and everything continues to work. If at a later point we get our connectivity back, we're able to sync and pull changes down from the feature service onto our device. So any feature changes that have been made to the backing feature service, we can synchronize to bring them down to our device. If we are using a pure read-only workflow like this, and we're using the pre-planned model, then we can further optimize this update by taking scheduled updates. So these are small change sets that apply to a pre-planned map area and are created on a regular cadence whenever that map is updated. What that means is an offline client using Runtime can look at the set of changes, the set of deltas that have been applied to that feature service, and download just the ones it needs to update itself. And that's an extremely quick, very scalable way of updating an offline map. Nick's going to give us a quick demonstration of this workflow for updating that offline map.
So let's take a look at scheduled updates. We'll start with what it takes to configure scheduled updates on your map. So here we have that same map again. It's configured for offline. It has 5 available map areas. We're going to jump in, look at these areas, and take a look at the configuration for one of them. Now, when we create these areas, by default, it'll just package them up afresh every so often according to the schedule, here every week at 1:21 p.m. If we enable scheduled updates, what the runtime will do is it will still generate that package, but it'll also generate a tiny delta package of only the changes to the data that have applied since the last package was updated. You can imagine we could do this every day, and so we'd have a tiny delta representing every day, and a map package sitting there waiting for somebody who hasn't already downloaded it so they can get the current state. So all these things are sitting there on the server, generated by ArcGIS Online or ArcGIS Enterprise. Let's take a look at what that looks like when it's being downloaded by an application. So here we have an iOS application. We can see here in the middle, there's an area that doesn't have any data on it at the moment. I happen to know that when I pull the scheduled updates down for this offline pre-planned map that we have on the device, it'll fill in some data there. So I'm just going to tap on the map to kick that off. Now, the first thing that happens is we find out how much these deltas would, how large these deltas would be if we wanted to download them. Yes, I do want to apply these. So we go ahead, download them, and apply them very quickly. You notice how fast that was. We didn't pull down the base maps. We didn't pull down the entire package. We only pulled down these 2 deltas that represent the changes that have happened since I got the original map downloaded. And then we apply them in sequence and bring our data up to date. If we look at this in code and see what's happening, it's really straightforward. We take that OfflineMapSync task again, initialize it with our local map. That's the pre-planned map we previously downloaded. And we check for updates. Now, we find out that there's some available, and we can find out how much space they'll take, how large they are to download. So here I just pop up that alert that asks the user if they want to download, and of course I did. And we jump in here, get the default OfflineMapSync parameters, and we just call OfflineMapSyncJob.start. What this does is it goes ahead, downloads each of those delta packages, applies them in turn, and comes back when it's finished. There's really nothing for us to do. There's one exception to that, though. Under some circumstances, the runtime will decide that it's actually more efficient to download the latest packaged up entire package and replace what's on the device already with that latest version. That can happen under 2 circumstances. The first is if the deltas actually turn out to be larger than the latest package that's sitting there on the server waiting, or if that breadcrumb of deltas from the last time that you downloaded the package to the device to today is broken in some way. By default, the server ArcGIS Online and ArcGIS Enterprise will keep 5 days worth of deltas. So if the last time you downloaded a package was, say, 7 days ago, and there are deltas missing in between, Runtime will figure out, well, actually, I can't bring you up to date with the deltas that I can download. I'll just download the latest package. And in that case, we have a flag here on the result that's returned to us that says you actually need to reopen this mobile map package. And in that case, we just close what we had already and we load the new one, and the runtime takes care of everything else.
Thanks, Nick. I'm going to take a quick look at that code that we used for performing OfflineMapSync. So as I mentioned, there's the OfflineMapSync task here. And rather than constructing with a web map, here we construct with our offline map on our device. Again, we load and wait, and we create default parameters from the task. And these will set up options for doing things like controlling whether we want to upload or download our changes. Next example was downloading changes in this read-only workflow. And then once we're ready with those parameters, we can sync the offline map. We'll get a job back, we start it, and we wait. And that job will represent the sync process. If there's any issues, they'll be reported in the result of the job. Okay, we've taken a quick look today at some of the different scenarios we could use for working with maps online and offline. In terms of licensing, The light license level covers most of the workflows that we've looked at today. Viewing maps, scenes, and layers from across the platform. They could be created from ArcGIS Pro. They could be authored in Runtime or in Online. We can also carry out simple routing and place finding with mobile map packages created from Pro. Other license levels become required when we start doing things like editing. And editing workflows is something that we're going to cover in the second session to do with the offline workflows. In summary, we've looked at the way that you need to account for connectivity when designing your application, especially when thinking about, is your app going to always be connected? Therefore, should use an online web map. Published from ArcGIS Pro. Or do you fall into the occasionally connected workflow where you might consider using the OfflineMap task to take your data offline? And when you're designing your map and your layers, you can also consider the update strategy that you want to use. So that helps you to work out whether it's data that is changing very often, that you need to be able to sync changes, or if it's infrequently changing data like a base map that you could maybe sideload to your device once and only update very occasionally. That brings me to the end of the presentation. Thanks for your time today. I hope you found another 2 sessions that are going to cover some more aspects of the offline workflow. Thanks.
Hi, everyone. Well, thanks for listening to that. My name is Nick Furness. I'm a product manager for the ArcGIS Runtime SDKs, and you were listening to Luke Smallwood, who's also here to answer your questions. He's product owner for the offline capabilities of the runtime. We've got some great questions in the Slido survey, and we'll try to run through them. We have a few minutes here, and for anything that we don't get to, please come by the Ask Our Experts runtime section, and we'll be able to address them there. So first question was, is there a way to dynamically switch between online and offline maps instead of having a user select to download and switch between online offline? And then a sneaky second part to that, also, is there a way to leverage loading a base map completely from storage to limit data consumption? Luke, you want to handle that?
Sure. Hi, everyone. Thanks for joining today. So for the second part of that question, is there a way to leverage loading a base map completely from storage to limit data consumption? That's a great question. We do have a workflow that specifically targets that need, because oftentimes the base map is the biggest thing that you're downloading. So the API that we're talking about here is called Base Maps by Reference, and it allows, in both the on-demand and the pre-planned workflow, it allows you to choose to leverage a base map that's already on the device. So we support TPK and VTPK. And the web map author can actually set that up ahead of time by saying, for this web map, when you take it offline, you should be using the name of my basemap.tpk when you come to take it offline. We'll be going over that workflow in a bit more detail in a session that we're running tomorrow, which is called Optimizing Your Data Workflows for Working Offline. And I believe that's at 7 o'clock PST. So if you can join us for that, then we can give you some more details and some demos on that one as well. As to dynamically switching between online and offline maps, that's kind of an app logic question. If you want to have multiple maps to let users switch between, then there's nothing to stop you doing that with Runtime. In terms of having an app that will work both offline and online, what we'd recommend is that you have the core business data is taken offline as a mobile map package, and you've kind of got that guaranteed to work regardless of your network situation. But we talked about it in the slides a little bit earlier on. You can have online data that will work when you have that network connection. So maybe you have a small section of your base map, which is offline as a TPK or a VTPK. But when you want to be working online, you could have, the whole world base map as a layer in your map as well. So hopefully that answers that question a little bit. But move to the next one, Nick.
Sure, yeah. Is there MMPK available for the world street, satellite, and terrain base maps without having to export with ArcGIS Pro? We do have StreetMap Premium as a product, which allows you to get both base maps and locators and network data sets as an MMPK. For satellite and terrain, we don't have a product for that. So you would have to generate your own. Can you create a route with an offline map, add multiple stops, and automatically generate the most efficient route?
Yep.
Luke, do you want to jump on that?
Sure, absolutely. So I'm just posting a link to a sample to that question. We've got a sample here, which is about offline routing. I've linked to the Qt version of the sample, but it's available for all of the runtime SDKs. You can perform offline routing. It's only available in a mobile map package that you create from Pro. So you can't take a web map offline and download a routing service that way. So you'd have to create the mobile map package in Pro, or use StreetMap Premium, like Nick suggested earlier on. But once you've got that offline transportation network, then you can perform routing with just exactly the same API. So it'd be the route task that you would use for dealing with that. Okay.
Great, thanks, Luke. The next question is there a limit on the number of features that can be synced, downloaded, and uploaded? I think you were going to take that one as well.
Yeah, so there's no hard limit on the number of features that can be synced, downloaded, or uploaded, but it is worth thinking about your workflow and thinking about whether you need to do both the download and the upload at once. The reason I say that is it can be a bit of a bottleneck if you have many users who are performing a download sync at the same time. And again, this is something that we'll go into in the optimizing section tomorrow. But essentially, if you're performing a download sync, it needs an exclusive lock on the feature service. So if you are doing very many download syncs, it can kind of slow down that operation for other users as well. Uploads, on the other hand, are cheap. So there's kind of no problem with doing many and frequent uploads. That doesn't lock the feature service. But downloads are something that you want to, do with care. And you also want to make sure you do these things when you have a stable network connection. So no specific limit on the number of features. They have to satisfy the definition query that you might have had when you took the map offline in terms of area and any attributes as well. Okay.
Thanks, Luke. Will there be a link to the samples? I think Luke addressed that a little bit earlier with the routing and offline maps. We've got sample apps we'll provide some links to here in the Slido answers. But we're not. I'm not able to share the demos that I showed during the session, if that's what you mean.
Yep.
Do pre-planned offline areas require ArcGIS Portal? Can they be published in Pro via an on-prem server features service? I think you were going to take that one, Luke.
Yeah, I can talk to this one. Yeah, so the pre-planned workflow is not something you can do from Pro itself. You will require a portal in some fashion, whether it's ArcGIS Online or Enterprise. That's because they rely on the web map, and it's all information about taking the web map offline. There is other API available for creating these things. You don't have to do it via the online UI. So I'm just posting a quick link to the REST API, which has a couple of scripts that you want to run for create map area and set up map area. So that's something that you can automate that way, or you can also do it with the Python API. But yeah, you will need a portal to stage and create these pre-planned map areas.
Okay, I think we've got time for maybe a couple more questions really quickly. Is there a way to get server edits, deltas?
Yeah. Okay, I can speak about this one. Yeah, quickly as well. So I think the question here is asking about, is there a way to get hold of the changes that we either upload or download when we perform a sync? We talk about those as delta files, so they kind of just say what's changed in a geodatabase as part of this sync. We do have some API added at update 10, I believe, which allows you to keep hold of those deltas. So it's part of the sync geodatabase parameters. What it won't let you do is get hold of those delta files in isolation. It will it will leave them on disk when you apply a sync. So if you're doing a download sync, we can leave the Delta file there, which is useful if you want to inspect it, or maybe you're troubleshooting something that went wrong with the sync. In terms of generating the deltas without applying them in runtime, that's not supported at the moment.
Thanks, Luke. Well, I think that's all we've got time for. We'll have to wrap up here. Luke and I will try to address more of these questions in the chat, but we've both got another session coming up here really quickly. So I do recommend you come by Ask the Experts, and we can discuss them in more detail with you there. But again, thanks very much for stopping by and listening, and I hope we found this helpful.